Hello everyone. In last lecture, we ended at absolute value of A less or equal to B or absolute value of A greater or equal to B. And we arrived at two conditions, A less or equal to B but greater or equal to minus B. Another condition what we arrived at was A less than minus B or equal to minus B or greater or equal to B. Now this sounds very tedious. So we will have to write better mathematical notations for all these inequations. So we define first what we mean by interval. So there are two types of main intervals. One is closed interval, and look at the notation what I have written. A comma B and within square brackets. That means you write two real numbers separated by comma. That square bracket takes our attention, and that is the main thing which is attached with closed interval. So we define now formally what we mean by closed interval. So closed interval is collection of all such numbers which are greater or equal to A and less or equal to B. Now this sounds quite a lengthy statement. So let us write it in more compact mathematical form. I write close A comma B, that means square brackets A comma B equal to, then I have written curly brackets, and those two curly brackets actually show that we are talking about the collection of numbers. I have mentioned that X, and then there is a notation called epsilon, means that stands for belongs to. Capital R stands for set of real numbers. So we are looking for all such real numbers such that they are greater or equal to A and less or equal to B. Now, once you are accustomed with all these symbols and notations, then you find it more easier to show a closed interval. Now this epsilon notation is something new to you. Those two curly brackets at the end is something new to you. I repeat that I have used that epsilon notation for belongs to. I am looking for some X which belongs to collection of all real numbers, and it is not just any number. I have taken a number X which is greater or equal to A and less or equal to B. Let us take some example. I take 3, 5. Means what? I allow X to take values starting from 3, means 3 is included. It can go up to 5. 5 is included, and any number between 3 and 5. So what we do? We mark on the number line 3 and 5. We show those two numbers 3 and 5 with square brackets. The square brackets tell us that 3 and 5 are to be included. And where does X lie? X can take any value between 3 and 5, including 3 and including 5. Now let us move to another type of interval, which is open interval, A comma B. Now how it is different from the previous one? The first thing what takes your attention is, instead of square brackets, here we have written round brackets. So obviously those brackets have their special meaning in case of intervals. Now let us define open interval. We say open interval is a collection of all such numbers which are strictly greater than A and less than B. Now again, this statement looks quite big, quite long. We write it in more shorter form. Again, I have used two curly brackets. I have written A less than X. I have written X less than B. And instead of writing it as two separate statements, we have included them in one. And I have written A less than X less than B. Now let us take example. I take example 3, 5 like previous. But here the change is, instead of square brackets, we have used round brackets. That means we are talking about open interval, and we allow X to take values from 3 and 5. But now we make sure that X cannot take value 3 and X cannot take value 5. So what we'll be doing? Can we actually write all those numbers which are greater than 3 and less than 5? No, it is not possible. So we take help of number line and we just show in picture form We plot 3, we plot 5, we show 2 round brackets, and then we say that x is somewhere between 3 and 5. Any value which is more than 3 and less than 5 will appear in that open interval. Now every time you need not have simply closed interval or open interval. It could be combination of two also. One end closed, other end open kind. So we define few more intervals. And if you allow me to take, I can actually write down 6 different intervals, out of which last 4 have some new notation that stands for infinity. And that is written as horizontal 8. Now what we mean by infinity? It is the right end of the number line, somewhere at the end. Is it a fixed number? No, it is not a fixed number. Now you can move to left of number line also, and that would be nothing but minus infinity. So last 4 have either plus infinity or minus infinity in them. Now first 2 are just written as closed at one end and open at other end. Now to make infinity and minus infinity more clearer, I write few examples. I write 3 comma infinity, 3 closed, and I have written open, that means round bracket at infinity. So condition should be x greater or equal to 3. So how do we plot it on number line? I will mark 3, I will write square bracket, and x can take any value starting from 3 and it can go up to infinity. Mind you please, though I have shown it by round bracket infinity, I meant only that x is on the right hand side of 3, and how much far you can go from 3. That you can go up to infinity. That means you can go up to the right end of the number line. Now I can take another example as 2 comma infinity. I have written 2 comma infinity means I will be marking 2, and on the right side of 2 I have to move till the right end of the number line. Now let us take examples where minus infinity is involved. And I write minus infinity comma minus 5. So how does it look on the number line? That you will have to mark minus 5 and you move to left of minus 5 and go up to what? Up to as much left you can move. So that is written as minus infinity. Now one more example, that is minus infinity 8 closed. Means you will have to mark 8 on the number line and you move to its left up to minus infinity. Means again no fixed position, minus infinity, but you can move as much as you wish on the left end, and minus infinity is expected to be extremely small number because you are moving on the left. Now these are the 4 types where infinity or minus infinity were involved in these examples, and other 2, first 2 what I have not written in the example, you can always try those examples by writing different values of a and b and actually mark them on number line and try to understand the importance of closed interval by showing square bracket and open interval by showing round bracket. Now let us take quick recap of what we did in the session. Now we used square brackets for closed interval and we included the endpoints by showing square brackets. We use round brackets for open interval and we do not include the endpoints of that interval, or I can say exclude the endpoints. And minus infinity and infinity are just symbolic representation. They are not any finite numbers and hence they are always shown by round brackets. So these intervals what we learned in this session will be useful in our further session. Till then, stay tuned. Thank you.